Okay. So, so I've made a very simple ray tracer setup. Let's do 0 here and like 3. Let's do the I don't know, 0 1 0, and this should be good. Just to prove. Oh yeah, not let's not do green. 0 0.5, 0 0.5, and yeah, 0.5. I think that does not hurt the eyes. Let's say. Oh yeah. So what are we gonna do? So I'm just gonna go quickly through this. So I'm using Svelte for the rendering, but it doesn't matter. It's not used at all. You can think of it as basic JavaScript. The only uh, weird part is this bind this canvas, which we can remove, and the unmount function. This is basically equivalent to window and event listener load, and then this with a little like some things, some extra stuff that if this thing gets destroyed, it's gonna call the cleanup. And yeah, I'm just gonna go through whatever we have here. It's a very basic setup. Uh, so we import the shader. I called it frag, but it's actually we have both the fragment and the vertex. For the vertex shader, we have the basic. We just draw a big rectangle triangle that goes out of the screen. And that's all, and then we set the UVs. This I haven't done, and it's weird that this is working because it should not work. Well, apparently it does work for some reason, which I have no idea how this is working. It's not even complaining that the uniform is not here. Huh. Oh yeah, that's I didn't know. Anyways, so um let's see. Alright, so I have a somewhat of a plan. I'll just write it here. Let's say we need this kind of comment. So what we're gonna do more or less is first create a camera plus uniform, camera plus size, screen size that we need to pass to the GPU. So as uniforms, so this should be this is our uniforms, and then all the other stuff is gonna happen here. So what we're gonna be doing is a ray tracer, ray marcher, something like that. Yeah, so this is this is a website where you can find some cool GPU animations, and let's see. So the main idea is gonna be to but basically what I'm gonna do is use SDL, which is sign distance. SDF, sorry, functions. So I was sign distance functions for my intersections for so, and let me go back to shader toy, and let's do SD, or let's just do browse and we'll see them. Probably, yeah. So this is the idea. So they use ray marching to intersect with all those primitives. So we're gonna try and implement a ray marcher, but with some tricks, maybe. Let's see how that goes. So first we're gonna need this. So once we have our ray marcher, we're gonna let's see. Let's do this, and then as we move along, we can see how things are gonna happen. Anyways, so what I have is basically I'm just gonna go through this. So the most important part is here. So I check if the web GPU is available. Then create an adapter, which I'm storing globally right here. That's all the requirements, more or less, to get a canvas that works with your GPU, or like whatever rendering context. That's basically saying, hey, I need a texture to the GPU, and the GPU is going to give you a texture to which you can render stuff, more or less. Then we load the code, which is this, basically this code here. And once we load the code, this basically compiles the code, and then we tell it, okay, like use this module as a vertex, and this module as a fragment. I don't even think, do we need this? Is this a requirement or not? Yeah, it was a requirement. Anyways, and we're telling it like, oh, use the automatic layout, which is basically leaves the GPU to decide on the pipeline's layout. The GPU is no, it's actually probably JavaScript or the web GPU API. It's going to decide this. Then we resize the canvas, and basically this is going to scale the canvas to the full screen, and then we attach some event listeners, and this defer basically is, so each of these functions will they return a cleanup function, let's say like animation frame. So this thing runs on each frame, and it returns a function that cleans itself up. So it cancels whatever animation frame was started, and yeah, Yeah, I called it defer, but it's probably not defer. Whatever. It just adds this to a global list of functions, and then at the end I call cleanup, which just basically loops throughout the functions and cleans up whatever needs to be cleaned up. So what I'm gonna need is my uniforms. So let's see how we're gonna do the uniforms. So either yeah, I'm gonna pass them as a struct from this side, and let's see. Let's make like the simplest uniform, which is gonna be plus I haven't used this that much, so I'm just gonna read a lot of, or read how this works from the Mozilla website. Let's see if they have anything about uniforms. It's more or less the same as this buffer, the vertex buffer. So let's see where is the vertex buffer created. So here. So yeah, I was gonna create a let uniform defer, and it's gonna be GPU uniform GPU buffer, probably just buffer. And I don't know if I have to take a look at the store to see. Maybe okay, I'm just gonna do it the stupid way and then see if we need to worry about that, which is here. So I don't know, we do this, and then we can do device create buffer buffer, and then here I'm gonna say size 0 for now, because I don't know what the size is gonna be, and usage is gonna be GPU buffer usage, GPU buffer usage, and uniform. Probably, I think usage buffer usage file table. Whatever usage can be specified, blah blah blah. I think for usage property, I don't know if you have an example of uniform example. Oh, maybe through this. Yeah, I feel like this is going to be good enough. So this is our structure, and our structure, blah blah blah. And I need the create buffer. Yeah, so I need this, copy this thing here, and the size. Let's think through this. Maybe go here first and create our struct what would we call it? Uniforms. And what are we gonna have for now? For now, we're gonna have a vec2 pose. No. Clean size vec2 f, I suppose, and time f32. I think this is good enough, and then put this here. And instead of resolution, we can uniforms, and it's of type uniforms. Let's see. This should break, and it's not break. I suppose it has like it's zeroed or something by default, and the size is 3 floats, 4 uniform buffer, and let's say const uniforms, and it's gonna be a float 30 float 64 array. Is that how they make it? Uniform buffer size divided by 4. The color is 4 32-bit floats. Oh yeah, so it's 32, the default thing. Yeah, never mind. Yeah, and we're gonna have 1, 2, 3, 4 of these. New. Can I do it like this? I don't know. I probably can. So let's say, yeah, let's put 4 here, and it might not work. So I'm gonna say it's gonna be uniforms length or byte length. Is it what's the size? What do they need? Because it's 4 bytes. Yeah, so it needs bytes. And let me see. Yeah, I don't. Let's make sure that. Oh yeah, this is working. Cool. And also I need to create a binding. Where is my binding? Version uniform, message variable. I don't. Transitions with uniforms, code, blah blah blah. Create shader module. Oh yeah, so I need to create this also. Bind group, which we do not need pipeline. Oh yeah, and pipeline. Are we recreate? We probably don't need to recreate the bind group, and I'll write buffer buffer 0 uniform values. Also, this thing is not needed, probably. Yeah, nope. Let's get this const. We created once, I think. Once is enough, and then we update the things as needed. And set the scale. There was something about making set bind group. Yeah, this is the thing. So this is what I need, actually. Bind group, and let uniform group, and it's gonna be of type GPU bind group, and did you mean GPU bind group? Oh, uniform bind group. And on draw, so we're doing all this nonsense. Let's make this 0 also for some reason. I don't know why. We'll be drawing green. Pass encoder set bind group 0, and this is gonna be uniforms bind group. Also, I suppose we have to, well, uniforms would be written every time, so we can do it easily. So, renderer equivalence of just get the GPU. Yeah, this also has to be done. Begin render pass. Oh, okay, so I still need the buffer to uniform buffer. I'm just gonna put it here too. Let uniform buffer GPU buffer, and this is, what did we call it? Uniforms. And this should be fine, more or less. Well, there is plenty of stuff that we did not do. So I suppose we can create a function update uniforms that we can call before we do this set pipeline. And yeah, let's see how bad this is. Do we have, yeah, we fucked up something. Binding index 0 is not present in the bind group layout. Ooh. Get bind group layout 0. Oh, I think we fucked up something here. Group binding 0 var uniform. This is here. Okay. Our struct, blah 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 blah. And group 0 binding 0. So group 0 binding 0, I suppose, yeah, you can put it on the same line. Oh, it's maybe in the pipeline also, I have to specify this. Value set 0, blah 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 blah. Bind group, there's, okay, so I create my bind group. Oh, yeah, I can check it from here, context configure, blah blah. This we don't care. This we don't care. And then, so we created our uniform buffer. We create our uniform values. We create our bind group. Render pass descriptor. Color attachments. Okay. Yeah, maybe do this thing also. Begin render pass. Set pipeline. Set. Is the order important? Probably not, but set pipeline. Set bind group 0. Yeah, I really don't understand why. So we have this group binding 0 var uniform. Oh, it could be because of this, so I have to do something like uniforms screen size var underscore equals or u, just for the, yeah, it was that. Anyways, for some reason what happens is this is basically removed. Found out this the hard way. Just I don't know why it removes the unused bindings. Oh yeah. The next thing is we were doing the update uniforms. So basically inside the uniforms set, and we're gonna set. So we're gonna set 0. Oh, what? What is set? Set array and offset. Oh, we don't need it. We can do it like this. So this is 0 is gonna be window or canvas, actually canvas width. Then 1 is gonna be canvas height, and then 2 is time elapsed. Why do I don't have? I should. Oh, runtime. You can find a better name for this. Uniform 0, 1, 2. Cool. And it's still working perfectly. So we update this, we set the pipeline, we draw our 4 things, and we finish this. We send to the. So now, if we got this working correctly, we should be able to. First things first, I think uniforms should be. Do I have access to the uniforms? let me see if I can access these. It probably can't. Oh, I can. Never mind. Not present in buying group layout. Yeah, no, I have to pass that. No, well, time, and maybe we can do this thing. We can just take this and use this. So let's call it. So we have from var uv equals flag data.uv. Get our UVs, and then we can let color is gonna be, let's call this iTime, just time is this, and here we are. Use call, and we should see something similar to this. Unfortunately, not. Weird. Huh. Oh. Okay, this is, sorry about this. I am probably doing something wrong, but I can't figure out what's happening. Am I? Wait a second. If I don't update the uniforms, so not updating the uniforms is fine. Cassette, canvas height, runtime. Is my runtime wrong or something? Runtime. Oh, it could be because of the runtime. Could be because of the runtime. Let's see what kind of runtime they use here. They use, what is this? Seconds. So I can just divide by 1,000. And oh yeah. Say it was just okay. Now we can do camera. I'm gonna move this up and keep these together, because all this is not, this is just the setup, this is the data that's interesting. And what we can do is probably get a camera. Let's see, 3D camera model. That's not what I meant. Camera model. No, I wanted to do something before that. So what they did is in they do render aspect canvas, informs, and yeah, they reuse the pass descriptor yeah, instead of recreating it every time. Right here in my draw, I do this. What I can do is create a GPU pass descriptor. Let pass this Tor GPU pass render pass descriptor and do it in init basically. Pass descriptor equals this. Yeah, with the clear color, because this was very useless. Let's put it straight here like this, and do this here, pass descriptor. But before we do this, we're going to do pass descriptor. Yeah, I'll just copy paste it straight, this thing. This is what I have to do. Render pass descriptor, this pass descriptor. Type, because of type 0 can be used to index type. Pass descriptor. Wait, did I make a blunder? Yeah, this works. Color attachments. Can I think I can do this. Yeah, color attachments. Type any because of type 0 can be used to index type. And the 5 prioritization of type. Well, if I do this or this, I suppose. Yeah, this thing is forcibly existent, does not exist on. What do I have for this? Pass descriptor, color attachments. Yeah, Typescript just being create. Oof, context here at init. Oh, yeah, and we did not init the thing also, which is weird. Create buffer. Huh. This is new. Fail to execute get current texture on JPEG. This is not configured. Yeah, I got it. And when do I configure? Create shader module pipeline. Blah 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 blah. I am missing something. I just can't figure out what the. Where was the context? Get context Format, yeah, exactly. Where do we use format? So we use format here, and get current texture. Oh, yeah, this. Basically, I have to do this thing beforehand. Probably here somewhere. It's not the best, but whatever. Anyways, so we have our rendering set up, at least the simple pipeline. Now what we can do is let's go and create our view matrix or camera. Hmm. Maybe actually instead of I don't know if I can if it's fine to do this. Can I do struct camera camera is invalid social type must have at least one member and let's say Z of type F32. I don't know if I can do this. So camera is this. Yeah, no. Forms invalid argument requirement as spacing forms are not met by 5 to set. There is not a multiple of the requested alignment 16. Huh. What if I put you here? Yeah, I can't have nested stuff. Or I would have to do some like whatever padding around, like A0 F32 B. Yeah. Oh. Hmm. Well, I would like to have the structs, but I feel like it's just gonna be extra work for no reason. Let's see. Probably not. Have a camera, or maybe have the camera struct. We're gonna open it like unwrapped here, and then construct it in wherever, in the maybe in the vertex or in the fragment shader. Yeah, probably in the vertex shader. Or just have another uniform for the camera. Anyways, let's see. What is the camera model for? I remember that they had a nice camera example, very basic. Max skyboxes, scale rotation, translation, metric space. And the camera metrics, yeah. Cameras map. In that fast we had a move F in order for perspective. So probably what we're gonna do. Yeah, this we don't care about this. Huh, it's fine. I think let's just hard code the stuff in the fragment shader, and then as we go ahead, we'll export it to become a uniform. So right now, just time. Does this work? No, it does not. Well, it's fine. Let's call this t, so we have our time, and let's start by returning 0, like 3, 0. Hey. Let's do a black screen, and we can do. I'm gonna create the first function. On fn ray march. Thanks for joining the stream, by the way. So what we need is a ray origin, which is going to be a vec2f, and a ray direction, which is also going to be a vec2f, and this probably is going to return a hit. And what the hit is going to be, struct hit, and let's say that the hit is going to have a hit boolean, and let's return hit. Is this how you create one? Hit 0, false. I don't even know how you create one of these. Oh, var red is of type hit, and then return red, just for now. And what we're gonna do, so I'm gonna need a const. It's gonna be step. I'm gonna need multiple constants. It's not step, it's max iter, I suppose. Let's say we're gonna move 100 times. Const, and let's say min dist, and the minimum distance is gonna be this. And here we're gonna create a loop for var I equals 0, I less than max iter, and I plus plus. Oh, and probably we need the position pause, which is gonna be a vec3 f, vec3 f. Is that the thing? That's the thing. And also this is supposed to be a 3, and this also is supposed to be a 3. What else do we need? We probably need a fn get dist p vec3f, and this should return a float. F32, and let's return. Oh, sorry, I didn't see your message. And 0. And all right. So what we're gonna do, I'm gonna get that D is gonna be get this, and the position at which we are right now. Let's start, or var, this needs to be a var start is RO, and then we're gonna get the distance at, or yeah, no, this is post, or yeah, let's call it just P. P is RO. I'm gonna get the distance to P, and and then say if D is less than min dist. We're gonna say that red dot hit equals true and red dot pause equals P and break. So we're gonna break if this is the case. If the if when do we break? Yeah, if the distance is less than the max distance, we break. Or yeah, otherwise we're gonna say P equals it's gonna be RD times D, yeah, plus equal, and that's all more or less. I think I might be forgetting something, so let me get paint. So this is what we're doing basically. We have some let's make a square. So we have some object here, and we are, yeah, this is gonna be disgusting. So we are looking from here, and what we do, yeah, and we have a ray direction, which is let's say for now it's where we are looking at. So let's say, okay, this is the direction of the ray. Maybe let's make it green, and we're looking this way, and this is our ray origin. So what happens is we start here. Yeah, that was, so we are here somewhere, and my cursor died. Yeah, so we are here somewhere. Then we get the distance to the scene, and let's say this is our object. So we get the distance, and the distance is basically calculated like this. Just gonna, I don't know how good this is gonna be. So I don't even know if I can I? Maybe I should have used Figma or something. I'd say this is a circle. It's basically like making a circle. I just don't know how to get the circle in the middle. I was gonna make a circle like this. Yeah, it's been a while I haven't used. So not the best. Is there like a vector graphics online? Something like GIMP. New project. Can I? Yeah, this is probably gonna be better. So let's say we are here. Can I fill stuff? Uh, anyways, so this is the center, and basically we are sending a ray or like a sphere. That's why I call it a sphere tracing in 3D. Right now we're doing it in 2D, so it's not a sphere. I have to make this huge. Finally, let's say that this is the center, so as soon as it touches, so we get this distance basically. Because the distance from here to the object is this. So what we're gonna do is we're gonna advance by this much, and this basically is gonna bring us here. Yeah, because this is our radar direction. So once we reach here, we're gonna redo the same thing, which is, so now we're at this spot. We're gonna draw another circle that is gonna tell us, okay, like this is where we hit. We're probably gonna hit somewhere around here, and then once the distance is smaller than this value, we bail out and we say, okay, we hit the thing and this is the position. And probably we will have to collect more information about like, oh, what kind of thing we hit and so on and so forth. But this is the basics for now. And yeah, get distance. I think one of the good resources is, what's his name? Toy Creator. I don't remember his name. Oh yeah. Is SDF. So he has like a set of distances for the whatever shapes you would want to make. So we can steal this one for the sphere. Well, we don't. Yeah, we can just write it ourselves. And let's say this is gonna be a F32 as the sphere, and it's actually not like this. It's more like this. And this is a F32S. This is R. I like to call it R, and it's the other way around, RF32. and P, this is the position. P and Vic 3F. And what? That's not my, oh yeah, the R. Here we are, we got our sphere. And let's do, I'm gonna take a break actually and come back in some time. Yeah. Um, um, Anyways, yeah, I forgot something. Just put a comment here. So this is Ray margin, and to this we have min dist and max dist. And let's say this also is going to be 100. So why do we need maximum distance, which I forgot, is, let's say if we shoot a ray this way, if this is the direction basically, our direction was this way, so we start by shooting this way. This is our direction, we measure this radius, we step this much by this much by the radius basically, and then we get the distance from, basically it's going to be from this point to the rectangle, and it's going to be some sphere. This is very wrong, like the center of the sphere should be here, so it's way bigger, and then we'll keep moving, and having a max distance allows us to bail out early. So we can do something like if d greater than max dist break. Oh, and anyways, and I need a point here, and this is not needed. Um, okay, let me hide this thing. What was the, yeah. Yeah, so we have this is our array march, get this, and here what we can do is maybe return the SD sphere P, and let's say the sphere is of size 1. Um, what else do we need? Uh, so what we need basically to call array march, we're gonna need two things. We're gonna need rd, like 3f rd. It's gonna be like 3 0, and I always get this, and var right direction, and ro like 3 0 f f, and we have to get those somehow. And maybe just for it's fine for now. Like this is fine for now. And trying to think of the best approach to rodent resistant. I was thinking what would be the best way to get the camera model. Which kind of camera are we gonna work with? Mm, 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 mm. Maybe, yeah. Uh, let's say, so let's say that RD, say it's UV, and we're gonna do, oh yeah, Let's do the simple thing. So what do we have? We have the position, the UV, and it's in uniforms. What is a normal FOV? Game FOV. Blah blah blah. White console is lower, 60 to 75. Let's see, 75 two rad regions, and let's say, oh yeah, this is gonna be our FOV. Float var FOV with this, and then here we're gonna do UV uniforms dot screen size, and we're gonna take, oh yeah, screen size y. Yeah, let's use y, and we're gonna divide by 10 of FOV. Let's see, so this is our right direction, and ray origin, yeah, ray origin 0 0 is good. And let's do ray march. Let's say this like var h is this, and then rd and ro, and if h dot hit, we're gonna say let yeah, again, just two different kind of returns basically. Here I'm gonna return one, and let's see, that did not work as expected. What did I do wrong? Screen size. So I'm getting the screen size, I divide by the FOV. Let me remove this nonsense. Yeah, I have to check my notes again. Yeah, I'll I'll get back to you after some time. Actually, I'm gonna take a break and probably do a little bit off screen. Yeah, thanks for joining.